turn back. Let us turn back to the partition issue here. Now, suppose we have a partition, we have a sample space which is given by this rectangular form, where this sample space is partitioned into five partitions, right? Now, this sample space is partitioned into 5 partitions, right? Now, if we define another event over this partitioned sample space, let's say this is this event, which is event A, right? Now, this is nothing but the arbitrary event which is defined over the sample space S, where S is partitioned into 5 partitions. Now, the probability of A is, now we cannot compute the probability of A directly from this sample space, rather from this partition, because this event A shares different characteristics from the different partitions. For example, this A event shares this area from partition B1, right? This A shares this area from partition B, and this A event shares this, right, this area from partition 4, and this A event shares this area from partition 5, and this event A shares this whole area from partition 3, right? So, what's the probability of A is nothing but the probability of this area, the probability of this shaded area, the probability of this one, the probability of this area, the probability of this shaded by red pair, right? So, getting probability of A is the sum of these all. That is why we say total probability. Can we represent this area by, for example, this area is A intersection B1, right? Whereas this one is A intersection B2, whereas this is nothing but A intersection B4, right? This small area is A intersection B5, whereas this huge area is A intersection B3, right? This area which is pointed by or shaded by the green pen is A intersection B1, where the circle as a whole is event A, which is donated by A, which shares different areas from these partitions. Therefore, these partitions that shares areas from A can be represented by these events, right? These events. So, probability of A now is probability of this event, right? Probability of A intersection B1 plus probability of A intersection B2 plus probability of A intersection B3, right? This one plus probability of A intersection B4, this one plus the last one, probability of, right, A intersection B5, right? This is nothing but the probability of event A is the sum of these events A intersection B1, A intersection B2 up to A intersection B5, right? And we know that probability of A intersection B1, that probability of A intersection B1 is probability of A intersection B1 is nothing but probability of A given that B1 times probability of B1. This is by multiplication rule, right? And probability of A intersection B2 is nothing but probability of A intersection B2 is the product of A intersection B2 times probability of B2 by multiplication rule. Therefore, probability of A is nothing but probability of A given B1 times probability of B1 plus probability of A given B2 times probability of B2 plus dot dot probability of A given B5, meaning that probability of A given that, right, times probability of this whole probability of this partition 5, right, B5 is nothing but total probability, right? Through this total probability, we are obtaining this event A, which is represented by the circle here. So, in other language, this probability of A is given by this one here, or by this one. A certain item is manufactured by 3 factors. Say 1, 2, 3. It is known that 1 turns out twice as many items as 2, and 2 and 3 turn out the same number of items during specified production period. If it is also known that 2% of items produced by each 1 and 2 are defective, while 4% of those manufactured by 3 are defective. These 2% and 4% are defective rates of each factors. All the items produced are put into one stock pile, and then one item is chosen at random. What's the probability that the item is defective? That defective item can be from machine 1, or machine 2, or machine 3. So, what the objective here is the total defective rate of the machines, machine 1, machine 2, and machine 3 on the course of their production. This is nothing but the problem that calls for total probability theorem. So let's follow this solution step by step. We do have 4 items to be divided. Here we need to define 4 items. What the first item is? The item is defective. The other 3, the 3 respective factors. B1 is the item is from factory 1. B2 the item is from factory 2. B3 is the item from factory 3. So B1 represents factory 1, B2 factory 2, B3 is about factory 3. Meaning here when we understand this problem set up as a partition, what is S now is the collection of these partitions, right? B1 is here, B2 is here, B3 is here. Now the sample space S is nothing but all about either getting an item which is produced from factory 1 or factory 2 or from factory 3. So this is a partition. Over this one, if I define event, which is A event here, this A event is about the item is defective, right? This defective item can be from machine 1 or from machine 2 or from machine 3. So what's the probability of getting a defective item? Is nothing but probability of getting A. But A can be, right, from machine 1 of this match area, or from machine 3 of this match area, or from machine 2 of this match area. So what's the interest here is getting this circular area of different factors, right? These areas are nothing but B1 intersection A, this one is B2 intersection A, this area is A intersection B3, I mean. So finding probability of A is finding the sum of these 3 events. We know that probability of B1 is 2 times of probability of B2. The production rate of machine 1 is 2 times of the production rate of B2. This is from the fact that these sentences. It is known that 1 turns out, machine 1 turns out, or machine 1 produces twice as many items as 2 is nothing but probability of B1 is 2 times probability of B2. B2 is machine 2, B1 is machine 1. So the production rate of B1 is 2 times production rate of machine 2 is from this note. And that 2 and 3 turn out the same number of items probability of B2 is equal with probability of machine 3. But we know that these three partitions make up this sample space. And from our axiomatic probability, probability of B1 is probability of B2 plus probability of B3 is 1. Probability of B1 is nothing but 2 times of probability of B2 plus probability of B2 plus probability of B2, because probability of B2 is probability of B3, right, from this part, 1 and 2. Therefore, wow, 2 probability of B2, probability of B2, probability of B2 is nothing but 4, probability of B2 is 1. Probability of B2 is 1 over 4, right? This is the probability of getting an item produced from machine 2 is 1 over 4. And we know that the probability of B2 is equal to the probability of B3, 1 over 4. But the probability of B1 is 2 times of probability of B2 from this noting. So the probability of getting an item from machine 1 is 1 over 2, right? So these probabilities could be known now. Probability of B1 is nothing but 1 over 4, 1 over 2. Probability of B2 is 1 over 4. Probability of B3 is 1 over 4, right? Conditional probability results that combines the defective rate, the probability of defective rate, given that each partition or each machine is all about conditional probability. The probability of defective item from machine 1 is this much, 0.02, which is given here. It is also known that 2% of items produced by each of 1 and 2 are defective, right? The defective rate of machine 1 is 2, the defective rate of machine 2 is 2%, right? So the probability of getting defective item from machine 1 is 0.02, meaning that probability of A given B1 is 0.02. This is from the conditional probability definition. The probability of A given B2 is 0.02. This is nothing but probability of A given B1 is 0.02, right? The same is true. The probability of A given B2 is 0.02. Here, the probability of A given machine 3 is 0.04, right? Therefore, everything is known now. So we can obtain the total probability that regarding to the total defective rate of the 3 machines, right? Probability of A, which is this circle representation, the total probability which is represented by this circle event in this rectangular sample space, which shares different characteristics from the respective machines, is obtained by this, right? So the probability of A given B I times probability of Bi, where I runs from 1 out 3, is nothing but this term plus this term, 0.02 is here, right? Probability of A times probability of B1, where probability of B1 is 1 over 2, 0.5, right? We obtain at the end of the day 0.05. What does it mean, this number? This is nothing but the total probability that the event to be defective. That defectiveness comes from machine 1 or machine 2 or machine 3. So 2.5% is the total defective rate of the sample space S, and if we define an arbitrary event